Hello everyone. So I'm delighted to be present in InnovaRobots edition for the third time. Thank you, Mr. Rida and Mr. Mohammed, for this opportunity. And thank you, dear Amina, for the encouragement. So let me introduce briefly. I'm Amal Sayari, basically ICT engineer, graduated from SUBCOM in 2020 and actually a PhD student with CNAS laboratory with Professor Slim Rkhis and in collaboration with some partners company with Dr. Ali Mabrouk. So today I will present a new technique in active cyber defense, which is the cyber denial and deception. As a new trend and a promising approach for cybersecurity. So I will detail how this technique can allow defenders to understand, counter, and prevent sophisticated attacks. So I will give a global view of the issues, solution, and the emerging trends. Before we dive into the specifics, let's take a moment to outline what we will present in this presentation. So we will start with an introduction of the defense picture and the defenders and attackers interaction. I will detail the problematic and the issues related to this topic. After that, I will explore and define our proposed solution. Then we will define how we can model the cyber denial and deception framework. Following that, I will explore and define how emerging trends in cyber denial and deception, and finally we will wrap up with a conclusion and perspective. So, first of all, in the battle between the hacker and the defender, the offense has the upper hand. In fact, attackers has the need only to exploit only one vulnerability or weakness in the system, but in the other hand, defenders need to protect against several and different potential attack vectors. Additionally, attackers need to operate in anonymity, whereas defenders need only to detect and identify these vulnerabilities. And also, in the other hand, attackers need to find an innovative and update their techniques to exploit the vulnerabilities in the system. And the defenders need to find and also need to update their defenses. The second point is that no organization is immune for cyber attacks. So even if platforms that are considered untouchable, like Twitter, have fallen victim to sophisticated attacks. So the second point also that the one that executes the ODA loop faster gains the battle. The ODA loop stands for observe, orient, decide, and act. So observe is how to gather information like data in the environment and the potential opportunities. Orient is how to analyze this information based on past experience or some cultural background, or also on personal basis. For decide, so we need to base it on the understanding data, so we need to find the course of action and the appropriate course of action, so we can analyze all of them and then evaluating the outcomes and the best course of action. And act, finally, we need to choose the best course of action and to achieve the predefined objectives based on the decision making. So here the idea is that the one that will win the war, he is the one that will execute this loop at first. What we conclude that we are confronted on a critical cybersecurity issue, so which is the unbalanced and asymmetric war. Because in the one side, hackers, we are confronted to well-funded and also highly skilled threat actors. But on the other hand, defenders are with limited budget and need to defend against complex texts, complex and hard work, because he needs to defend a big and complex IT infrastructure. So this is what creates the asymmetric war between defenders and attackers. So to dive deeper into the problematic, so the first point is that the attackers need to be right once. So the attacker need to has one shot success situation, so they need to only exploit one vulnerability. But the defenders should have everything well set. So the defenders need to be right all time, not only once, because they need to protect all threat actors, potential threat actors. The second point is that attackers have exact information about the victim. So in reference to meter attack, attackers have several techniques to make reconnaissance, to infiltrate networks and compromise the systems. So they can gather a complete picture of the information about the target. But in the other hand, defenders have false positive. So the false positive are the legitimate events that are mistakenly detected as threats. So here also the defenders is in the bad position. The second challenge is that the attackers can choose the time and place of the attack. So attackers can choose when and where to attack, but for the defenders, they be prepared all the time. So defenders need to protect all the system components, need to be ready, their vigilance need to be maintained constantly. So this is the problematic, the general idea. So given the sophisticated cyber threats, which are multi-vectored, multi-staged, and with polymorphic properties, the second point is that traditional cybersecurity solutions like IDS, APAs, firewalls are struggling to defend against those sophisticated attacks. And here, the third point, that the traditional security solution have a reactive incident response. Also, defenders has to analyze CM console logs, has to make log crunching. So this approach is a reactive approach. So instead, with this sophisticated attacks, we need a proactive approach. So that's why we talk about this new trend in cybersecurity, which is the cyber denial and deception. So now let me define this system. Cyber denial, cyber deception focus on altering adversaries' perception of computer system in a way that can confuse their belief, decision, and action, leading them to waste their time and resources. So the idea behind cyber deception is to hide the real and reveal the fake. We need to hide the real assets in our information system, the real file, the real valuable data, and reveal the fake. We can make fake information like honeypots, fake files, and others. And the idea behind denial is to prevent the target from perceiving information, mainly by blocking access. So to better understand the deception solution, so let's take this illustration. So imagine in a network that we have a pot of gold. So this can be a valuable data, scripts or source code or others. And at the bottom we have an attacker that wants to take this pot of gold. So we as defenders, we can add some barriers like some firewalls to protect this pot of gold, or also we can add some monitoring system like IDS, IPS. But in this situation, the attackers still have a path to get this pot of gold. So why this attacker can defeat us? So here the situation is simple because we as defenders, we have played once, we have set our detective and the protective controls at one time. So the attacker will say, if you, I see your defenses. If you have an IDR, I will detect it. If you have a WAF, I will detect it, and so on. So here, how can we change the game? So here, as defenders, we can add other pot of gold, which are our deception resources. But here, only one pot of gold is real, and the others are fake. So the question here, we can put ourselves in the place of the attacker, which pot of gold to choose. So here the attacker is in the problem. Earlier the problem is on the defender. Now the problem is on the attacker because he has not good data. The entire network is unpredictable. So he cannot make a difference between the pot of gold. So, and if he will choose the fake one, he will be detected by the defender. So this is the idea behind the cyber deception. So with this illustration, attackers will be, we move the problem from the defender and we put it on the attacker, because earlier the problem is on the defender. He has several data to analyze, more devices to harden, but here the problem is on the attacker. He cannot make good decision. So now let's talk about the benefits and outcomes of using cyber deception as a security solution. So the first benefits is earlier threat detection. So using a decoy system, we can engage with attackers and collect intelligence about them. After that, this allows a rapid response. So by automation in cyber deception and the use of honeypots and others, we can respond to attackers automatically. So also it gives an improved efficiency, because the use of cyber deception need highly expertise from a human to analyze and to find the best solution. After that, this offers an enhanced scalability. Deception solution allow us to prevent several threats and prevent also future threats in complex networks. And finally, this allow us to reduce the false positives. As I said, false positives are the legitimate events that mistakenly detected as cyber threats. So cyber deception will reduce these negative points from the defense side. Then, to have a good cyber deception framework, so we need to base it on these 5 key points. First of all, we need to identify our attack surface. The denial and deception solution will also need to better understand the attacker. So here we can refer to the cyber kill chain or the meter attack framework to define which category of attackers we can deal with. After that, we need to fix our deception tactics. We need to fix our deception techniques, and then to make the evaluation. So first of all, for the cyber kill chain, we have 7 stages. The first stage is the reconnaissance, which means to identify the target. So here, the attacker will use some techniques to identify the victim and to collect intelligence from the victim. After that, the second stage is weaponization. So here we will prepare for the operation. The third stage in the kill chain is delivery. So here the attacker will launch the operation. After that, he will gain access to a victim. The next step is that the attacker will establish a malware or a virus. Then he will remotely control the implants, and finally he will do the action. So he will achieve his ultimate goals. So those are the 7 stages of the cyber kill chains, which is a high-level representation of the attacker. And here the idea is that cyber deception chain will be adapted to this cyber kill chain. So for each stage, we will find the appropriate cyber deception technique to use. Then to more represent the attacker tactics and techniques and move from the high level, this high level and abstracted model to a more detailed model, we can use the meter attack framework. So meter attack framework englobes 14 tactics, which are reconnaissance, resource development, initial access, execution, persistence, privilege, escalation, defense, evasion, credential access, discovery, lateral movement, collection, command and control, exfiltration, and impact. Those are the enterprise tactics that attackers usually use to infiltrate networks and compromise systems. And for each category, he has the appropriate techniques that he can exploit to exploit the vulnerabilities. So here the idea is that our cyber denial and deception framework will be adapted to each technique and tactic used in this framework. After defining which type of attacker we will face, so the second point to have a good framework is to focus on the attack surface. So here we have network attack surface, software attack surface, physical attack surface, and deception attack surface. And here the deception can be appropriate for each level, because in a network, we have the application level, software, data level, and others. So our solution needs to be updated to those levels. After that, we need to identify the exact deception tactics. So as I said, we have 2 main objectives. Either deception, which means mislead the attackers by hiding the facts and revealing, hiding the real and revealing the facts, or by denial, which is or denial, which is to deny access to the target. The next point is the deception techniques. So here we have several. The basic one is the honeypots. This is the first deception techniques used in the literature. Then we have the evolution, with the evolution, so we have other deception techniques. So we have the honey networks, which include the honeypot, honeypots, and others. We have the honey database, the honey files, honey operating system, honey email, honey API, or honey account. So we can focus on those elements to prevent the attacker. After that, once we have defined the appropriate type of attacker that we face and the appropriate technique and tactic to use, now we will move to the evaluation of our plan. So to evaluate the deception plan, so we have this cycle or this chain. First, we need to design cover story. We need to design the perimeter of the attack. After that, we need to plan to identify which technique to use. Prepare, we will prepare for the used attack technique. Execute, so we will execute our deception technique. Then monitor and reinforce, so we will see the impact of this deception technique and take a new decision. So for the attacker side, so he can, after the deception, so he can believe this action. So here the defenders will be the winner. or the attacker will suspect or disbelieve this deception strategy. So here we need to re-evaluate our deception plan and to have another plan. So this is the global idea on how to model a good cyber deception and denial framework. Now we will move to the emerging trends or the utility of cyber deception. So for the emerging trends, the first trend that I will discuss is the use of reinforcement learning. So as I said, so deception can be a promising cybersecurity approach for this new sophisticated cyber attacks. But here, to have a better framework, we can use the reinforcement learning. For my case study in my PhD, I used the reinforcement learning for two goals. The first goal is the cyber deception strategies and tactics selection. And the second goal is the placement of these resources in the network. So this is the two utility of reinforcement learning. The second trend is the use of game theory. In fact, the interaction between attacker and defender can be modeled using game theory. In the literature, there are several types of games that we can use. For my case of study, I used the Stackelberg game. So, and the objective of this use is to maximize the defensive posture and minimize the effectiveness of the adversary's tactics. The third emerging trend is cyber counter deception. So this is another potential field to discuss, because nowadays attackers are also intelligent. So we talk about the anti-honeypots. Attackers have their intelligence, they can adapt and innovate, and they can adapt their techniques to bypass defenses. So in this case, attacker also, they can exert a deception on the defender. That's what we call the cyber counter deception. So here we need to face those types of attack also. And the last mentioned trend here is the application domains. So for my case of study, I apply the cyber deception and denial for enterprise networks. So, but there are several other cases of study for deception and denial. It can be applied to industrial control system, to the Internet of Things, for example, by placing honey access point or honeypots or others. We can also use it for critical infrastructure protection. We can talk about fake signals and others, and also we can use it for UIV security. So those are the application domains. So to wrap up, so I define and discuss a global idea about the cyber denial and deception. I detail some sophisticated attacks, so denial and deception and their usage. Also, I give a global framework how we can model it, and for the emerging trends, as I said, so it can be applied in any domain. For our perspective, so we can work on the automation and orchestration of this solution. We can also integrate the behavioral analysis of attackers. Also, we can use the reinforcement learning game theory as promising technology for this field of work, and so on. So I want to say that this is a part of my PhD thesis. So I'm working with on the reinforcement learning and game theory as collaboration with two universities in Canada and Germany, and I'm open for any other collaboration. And also I want to thank Mr. Anis Zahri, because he was my supervisor in my graduation internship in Sama Partners, and now he also work with me on this promising approach. So thank you all for your interest.